please like and subscribe to my dad's channel so we can have more viewers and subscribers.
Hi, in this video we're going to create levels with our meshes, create data assets from it, and use it to spawn stuff using PCG. Let's go. So here are meshes we got from Minecraft. We have some buildings, walls and towers that we can use to build castles. Now let's create an enum and fill it with level base names. They will be used to tell a PCG system what type of level we want to spawn. Let's create an actor blueprint. Make sure it's set to be editor only. Add variable of type of our enum. Add ID integer to set level ID we want to spawn. We also have text variable to set text for a label on top of an actor. In an event graph, let's create a custom event. Make sure to set it to be run in editor. First, we get all the components by delete tag and destroy them using reverse loop. Next, based on a level type, we create some colors and assign it to helper color variable. Then convert level type to a string, append ID and set it to tags of our actor and store it to a label name. Let's add text render component. Set its tags to our deleted tag. Set text color to our helper color. Set text value to our label name. Let's create dynamic material. Set some parameters so that we can rotate text using material and apply it to our text component. Same way, we need to add pointer mesh. Add static mesh, set tags, create dynamic materials, and set parameters. Basically, it's that thing that lets us identify and select our actors in a level. Next step is to create level instances that we want to spawn. We already created a lot of castle islands and just villages. It's pretty straightforward. Add meshes and save it into packed level instances. Here we just keep brushing using our meshes to get another castle level. After you created levels that you want to spawn, select them and create data assets. Next, let's create PCG volume. First thing we do is collecting all our spawners by actor class. Then we running it through a set filters. These are regular PCG subgraphs. You can create them by selecting nodes and collapse them to subgraphs. Here is our Minecraft levels filter. So what is basically doing is filtering incoming data, and if we find matching tag, we spawning points from according level and outputting it, and so on for every tag that matches our level name. And if you want to add a level spawner, just drag and drop level data asset and set it to instance. Now then we created point data from level data assets, we can use a static mesh path and its tag in a point data to spawn it. Basically, static mesh tag is used so we can control parameters of things we spawn, like distance culling, collision, so on. For example, small bush don't need collision, but can be culled by distance very close. But huge tower need collision and needs to stay much longer. So to automate the process of assigning tags to static meshes, we need to create another editor utility blueprint. Here we have a dictionary that uses asset prefix as a key and tag as a volume. In this function, we first rename selected static meshes to its asset name. Then for each selected static mesh, we loop through keys in that dictionary. And if we find the key that matches prefix of asset name, we set tag from it. For example, here is one of the castle levels. This tower has generic name and no tags. PCG will not spawn it because there is no matching tag in it. So if we run the script, name is set to asset name. Also now it has correct tag. Now PCG can find data and spawn it. So now we can just bring our level spawner, set its transforms, and then we can select level type we want to spawn and an ID of the level of this type. With this approach, it's very easy to create big worlds, tune what each area looks like, and you can always go back to levels that you created, adjust what is being spawned, click to update on level data asset, and PCG will update that area. Remember, you can always go back to Minecraft and redesign meshes, re-export from Houdini, re-import in Unreal. This is very fast, non-destructive way I like to use for this project. Thank you for watching. Hope you try this approach. And like Kid said, please like and subscribe.